Hey, Year 10, this is our introduction to our next unit and also to the online learning platform that I want you to use for the first, hopefully only the first couple of weeks of this term. Hopefully we will be back at school. Now, the first thing you need to realise is that I have changed the scope and sequence around for no other reason than the work that we were meant to be doing in term 2, which you can see here from our scope and sequence, was probability and data, is difficult to do via an online platform. I'd rather do that when we're back face to face. So essentially, I've reworked it and I've just swapped the work we were going to do in term 2 to term 3 and the work we were meant to do in term 3 to term 2. So when you look here in term 2, you will see our outline, and it'll be done in, go away, you keep telling me this. Our outline is a little bit different because it's not done as timetabled lessons. It's done as you do a little bit of maths each day, half an hour, sometimes a little more, sometimes a little less. So you can see here for the first 2 weeks, 5 lessons each week. And what I've done is I've put each work for each lesson with the learning intentions, and whatever it is that you need to do is listed there with solutions. And I'm going to put videos up or YouTube clips up. The other thing is, if you want to get all the worksheets in one go, if you just scroll down to the bottom of the page, right down here, you will see I've put all the worksheets as a downloadable PDF file. And you'll also see that when I did this, in 2018, I've put the lessons and the board work on that we did back then in 2018. So you can have a look at where what they were up to at the same time, but you'll have to ignore the dates because the dates are for term 3 as opposed to term 2. So let's go back to the top. Oh, come on. Let me have you. Oh, I'm going to have to do this. I didn't want to do this. Come on. Righto. All you have to worry about is each week I'll put this up and you can have a look at it each week. So the first bit is actually grade intercept worksheets, but I want to do an introductory video into how we can graph straight lines because this whole thing is about linear expression. So we're going to go to the textbook and we're going to do some of the questions from the second lesson, which is exercise 5E question 7, but I'm going to do them via plotting points. So here we are. Now you'll notice also that I skipped 5A, B, C, and D. That's because they're just linear expressions or expressions in algebraic terms, which you already have the basic grasp of. So what I want to do is I want to go back to the very beginning and say, well, when you were in year 8 and year 9, you could plot or do a linear expression, a linear graph by plotting points. And remember that this is always a fail-safe method for you if you really run into trouble. So graphing linear equations by plotting points. And you can do that for any function. Remember, you choose the points. Now we're going to be using this form of the equation, although you'll notice that we'll be using a C because the new Board of Studies in year 11 and 12 have changed it, or the new documentation have changed it to a C. And we want to keep in line with what you're going to be doing later on in year 11 and 12. So let's go down here because it's all about plotting straight lines, and this is what we're doing. So I want to have a look at exercise 5E, question 7, and I'm going to have a look at D, H, and L. And you don't have to do these. Once you understand and you remember how you did these way back in year 8 and 9, you can move on. This is just an introductory YouTube clip. So let's have a look at this. So I'm graphing linear equations. So they're straight lines. and we're going to do it via plotting points. Now, you'll notice in the textbooks that they would write their points in a box like this, and you need to be able to understand that, you pick the x value, you put it in, you got y equals blah, blah, blah. You pick the x values, and then you get the y values, whatever they are, along here. And there you go, you plot those points. I would prefer if we didn't do it that way. I would prefer that if we wrote our x and y and went down the page, because then when we plot them, we're going to get a set of coordinates. So let's have a look at the first one, and it's pretty easy because the equation is written in the form y, so this is 7d, y equals 3x minus 4. And we're going to learn to do this a different way later on. You already know. So I've got my x, I've got my y. Remember, you choose the values, but I always choose -1, 0. Oh, that's a terrible 0. 0 and 1. And the reason I pick a negative or -1, 0 and 1 is because they're easy to input, and 0 will give me the y-intercept, and I get a -0, the y-intercept, and a positive value. I pick 3 points, right? Only to make sure in case I get something wrong. You really only need to pick 2 points to plot a straight line, but I pick 3 points. So what do? I now substitute these x values into this formula here. So to get the y value, I go 3 times -1 minus 4, and that's -7. You can check it on your calculator. 3 times 0 minus 4, well, that's -4. And 3 times 1 minus 4, well, that's -1. And I know I'm right, and so should you, because this is going up by 3, and if it's going up by the same amount, it's a linear expression. Now, I wouldn't write all that. I do all that on my calculator, and all I would do is I go -7, -4, -1, and look there, I've got my 3 coordinates. So then what do? Well, then I go, and this is why this method is hard, because to be accurate, you need to have grid paper or something very close to grid paper and be very accurate. So it's going to be hard because I'm using OneNote, and I know I've got a ruler up there, but I haven't got the exact amount, so I'm going to be doing it by eye, which is not a good way. So I've got -1, 0, and 1. And the first point is -1 and 7. So I have to go down 7 spots. 1, 2, 3, 4, 5. Haven't got enough. 6, 7. So about here. I'm going to draw a really big dot to make up for the error that I'm going to have. The next one's 0 and 4. So 1, 2, 3, 4. There. The next one's 1 and -1, which is there. So now I get a ruler, and I draw a straight line through those 3 points. And if I was very accurate, I'd get that point. I'd be able to read it off straight from the graph. And to me, it looks like 1.5, a little bit less than 1.5. If I'd use grid paper, I would be able to tell you exactly. So what I'm going to do is I'm going to write this equation, y equals 3x minus 4, on Desmos and find that exact spot. So y equals 3x minus 4, and there's that spot there, and it's 1.333, or 1 1/3. Let's have a look. There's my 0 and 4. Remember my -1, my 1 value, which is, if I slide along here till I get to 1, 1 and -1. And down here, it was -1 and a bit too far. There, -1 and -7. Righto. Well, that's pretty easy. But what you need to be able to do is rewrite the equation, because in the next one, it's not as easy. They give me the equation as 2x minus or plus 5y equals 10. Well, I have to write it as y equals, so I'm taking that 2x over. I get 5y equals -2x plus 10. And I divide by 5, I get y equals -2/5 x plus 2, because 10 divided by 5 is 2. I keep my same 3 points. You can choose other ones if you want. In fact, probably be good to choose -5, 0 and 5, because then you'll get rid of the fractions. But I'm going to keep it as -1, 0 and 5. And because I'm going to do a difficult calculation, I'm going to use my calculator. So I've got -2/5 times -1 plus 2. Twelve on 5, 2.4 or 2 2/5. So -2 2/5. Come on, eraser, where are you? All right. 2 2/5. And if I put 0 in there, I'm just going to get that. So I'm just going to write the 2. And if I put 1 in there, well, I could go back and use my calculator. Delete that. And I get 8/5, which is 1 3/5. I go over to my graph. I get rid of that previous line. I'll leave that in there. Get rid of these. If the eraser starts working. Right. So -1 and -2 2/5. Sorry, that wasn't -2 2/5, that was 2/5. I forgot to rub out the negative. So 2 2/5, so -1, and I have to go 1, 2, and 2 2/5 is about there. I've got my negative, my 0 and 2, and I've got my 1 3/5, it's about there. Now, if I do big dots, hopefully I'll masquerade or mask the error, because I haven't done it as accurately on grid paper, and that's no good. Come on, where's my eraser? Come on. Thank you. Why are you so slow? Righto. Here we go. Let's try that again. I'm going to have trouble with this. Get rid of that again. Try again. That'll have to do. And as you can see, I haven't got my graph long enough. And I'm going to go, 1, 2, 3, 4, 5. Somewhere, it's not accurate, somewhere around between 5 and 6. Let's go to Desmos. What was the equation? 2x plus 5y, 2x plus 5y. So we'll type it in exactly the same way. 2x plus 5y equals, what was it? 12. Go back and check. 10. And here we can see it actually goes through 5. There's my 2. What was my 1 value again? 1 and 1 points. 1 and 1.6, and the negative 1's there. So there we go. Now, I was going to do the third one, but I'm going to let you go now because you should remember how to do this. This other one, you'd have to rearrange it, pick your points. But that's graphing equations by plotting points. Good luck.